Hey guys, this is the 2023 and Math Counts chapter run sprint number 26. Okay, so we want to just evaluate this expression and write the answer as a common fraction. Okay, so whenever you have a radical, you want to really find some perfect square because that's the square root. So and then look at the numbers you are given. So that's 45. So I can just take this as 9 times 5. So I can say 9 and 5. And it is better to write it separately if you feel better to do so. And that's going to be 2 root 15. Okay, so that is my numerator. And then this guy is 64 times 2, which means I can write 64 and 2 separately because this is a perfect square. And then 2046 times 4, so I can write as 2 times root 4 and root 6. Okay, so I can pull this 9 as 3, so that will be 3 root 5. And then this is 2 root 15 because 15 doesn't have any perfect squares divisor, so we cannot pull anything out of that radical. And then 64 is just 8, so I can just write 8 root 2. And then this is square of 4 is just 2. 2 times 2 is just 4. So I can write as this guy. So at this point, like there are a couple ways you can attempt to. So you first things maybe you see root 2 and root 6. I can maybe pull those root 2's because this guy can be written as like root 2 times root 3. And then you have the numerator as root 5 and root 5 times root 3. So you can pull those if you want to. Which is I'm gonna do actually. So like this guy is root 3 times root 5. So that could be written 3 root 5 plus 2 times root 5 times root 3. So when you have a number, so you can split as a product. If they are split already, then you can combine in under one radical. That is okay with multiplication, with the division as well. Okay, and the same thing will be in the denominator. So this guy could be written as root 2 times root 3. So now I pull the common stuff that I will pull. So that will be root 5 for numerator. And then if I pull root 5, so there will be 3 left over. And then that will be 2 and root 3. So 2 root 3. And if you want to double check, you can expand this, right? So if you multiply this by that, so you should be getting this guy. And if you multiply this by this, you should be getting these three products. And this numerator is, so we denominator, we have root 2. And so I could have, actually, I do have 4 as well. So maybe I can pull 4 as well. So if I pull the 4, this is 4 times 2. I pull the 4, so I will get only 2 left over inside. I already took the root 2. So I took 4, and then I took root 2. So root 3 is the only one left over. Okay, so this is what I have for now, but it doesn't really look nice at this point, right? So I do have a irrational sum in the denominator. So in order for us to get rid of that irrational part, we take the conjugate of this expression, which is the negative version of the radical part. So 2 minus root 3. And then I cannot play favorite, so I need to do the same thing with the numerator so I can actually have the same question. So if you multiply 2 plus root 3 by 2 minus root 3, which will be just 1, if you do remember the difference of square, if you don't, just multiply them. So 2 plus root 3 times 2 minus root 3. So 2 times 2 is just 4. 2 times negative root 3 is just minus 2 root 3. Root 3 times 2 will be 2 root 3. And this time this will be minus, that will be root 9, which is just 3. So these guys just 0. So 4 minus 3 is just 1, which is what I said. And now if you multiply the same thing with the numerator, so I will just leave root 5 for now. I'll expand it after. 3 times this guy will be 6. 3 times this guy will be 3 root 3. And 2 root 3 times 2 will be 4 root 3. 2 times 2. And then this guy times this guy. So 2 times root 3 times root 3. It has to minus, but root 3 just 3. 2, 3 is just 6. So that is my numerator. And then again, we multiply these two guys. That's just 1. So 4 times root 2. So this is add up to 0, which is nice. And then you have root 5. And then 4 root 3 minus this guy will be root 3. And then divided by 4 root 2. Again, this is still irrational, so we need to multiply this by something, which is √2, to make that rational. Okay, so then we are going to end up getting multiple of those three numbers. That will be, so 630. So √30 over √2 by √2 just 2. 4 2 is just 8. And I think that's my answer. So it looks like too much work, but at the same time, it's not really bad, to be honest, for number 26. Okay, so there might be some other ways. Like, you don't really need to put those √5 or √2s as I did. You can just multiply in this step, maybe actually in this step, by 8√2 minus 4√6, and see if that's gonna eliminate some of the radicals. And you can go from there as well. But I think this is okay to do so. Okay, I hope it was clear. I'll see you in the next video.